Hello and welcome to Mr. Thompson's Math Tutorials. Today we're going to be looking at two things. We're going to be looking at completing the square and perfect square factorization because these kind of are opposites of each other. They're a little bit like that difference of two squares in the last video I made. So let's look at completing two squares, okay? Completing the square here. So here we go. What we're going to do is we're going to look to see if we can develop a pattern based on what we see here. So let's FOIL this thing. Let's start by doing that. So to FOIL, what we do is we do first, outside, inside, and last. Okay, so here we go. The outside, first is going to be that times that, so it's going to be my x times x. Oops, it did that in the wrong color. So here, hold on, let me just get the correct color. Okay, there we go. First times first. So this is going to be x times x. Okay, then what we're going to be looking at is outside times outside. So that's the outside, that's the outside. So this is going to be plus x times 5. Okay, then we're going to be looking at inside. So that's this 5 times this x. So I have plus 5 times x. And then we're looking at last times last. So this is that positive 5 times that positive 5. So this would be plus 5 times 5. Okay, I'm going to collapse this thing together, and then we'll see if we can see a bit of a pattern that goes on here. So starting with the x times x is x squared. The green term here is going to be 5x. The red term here is going to be 5x. And the black term here is going to be 10. Oh, sorry, not 10, 25. What am I doing? Plus 25. There we go. That's correct now. Okay, I can simplify this a little further. I get my x squared. I get my 10x plus 10x here because 5x plus 5x is 10x. And then I get plus 25. Okay. Now, we can notice a bit of a pattern. Okay, so first, kind of like the difference of two squares, we can notice that the first term in this is squared and the last term in this is squared, right? X times x is x squared and 25 is 5 times 5. Okay, so those are two perfect squares. Now this 10x in the middle has a bit of a pattern going on. If I think to myself that this is basically, this is my first term, which is x, times my last term, which was 5, and then I have two of them, so this is times 2. So if I look at this, this is 2 times 5x, so this would be 10x. Now we can write this, sorry, that's a 10, not a point. There we go, that's 10x. Okay, so we can actually write this in sort of a formula that we would use. So let's have a look at that. So here we go. Not a formula, but just some way that we can remember this. And this is it here. You can see that whenever we're multiplying the same thing, like x plus 5, times the same thing, like x plus 5, okay, we're going to get our first term, which is in this case x squared. We're going to get our second term, and that's going to be our first term, which is x, times our second term, which is, our first, x times 5, so that's going to be 5x times 2. So in this case, x times 5 is 5x times 2 would be 10x. And then our last term for this is going to be b times b, which in this case is 5 times 5, so that's going to be 25. Okay? Now, of course, when we see this pattern, we can undo it and understand that this is going to lead us back to here. Okay? So what we have to try to see, is it possible that this right here, because we want to put it back into the form, we want to undo these things as well as expand them. So we want to factorize and expand. So is it possible to see if this is a perfect square and that's a perfect square? If they are, we have to ask ourselves, is the square root of the first term times the square root of the second term times 2 equal to the middle term? So we can see that in this case that it is. This is a perfect square and its square root is x. This is a perfect square and its square root is 5. 5 times x is 5x. And then if I multiply that times 2, I get 10x. So I can know that this is a perfect square. And when I'm factorizing perfect squares, I just go backwards on it. Okay, so this would be this. Okay, so let's look at another example. Let's look at this example here. Oh, that's the example we just had. All right, so let's look at a different example. Okay, so I'm looking at this example right here, thinking to myself, can I factorize this? So I look at it first and I think to myself, okay, is 4 a perfect square? And the answer is yes, it's a perfect square, and its square root is 2. Is x squared a perfect square? The answer is yes, and its square root is x. Is 25 a perfect square? And the answer is yes, and its square root is 5. Now, can I multiply these together and get 40x, or multiply them together and times that by 2 to get 40x? So let's see. 2x times 5 times 2. So 2x times 5 would be 10x, times 2 would be 20x. So 20x does not equal 40x. So this is not a case where I can do the perfect squares. If this was written like this, if this was 4x squared plus 20x plus 25, it would be perfectly a perfect square, and I could factorize it. But unfortunately, it's not. Okay, so I can't factorize that in the same way. Probably I would have to use the quadratic equation on this particular question. But let's see if we can factorize this one here. Okay, since we know that this is a perfect square down here, what I would end up with would be 2x plus 5 times 2x plus 5. Okay, and that would be factorized. All right, let's look at another example. In this case, I want to look at this and think to myself, is 20 a perfect square? No. X squared is, so that is a perfect square, and x is its square root. 125 is not a perfect square. So, but can I factor anything out? Well, if I factor out, let's see, 5? The lowest common factor here would be 5. So I'm going to factor out a 5. So 20 divided by 5 would be 4x squared. 200 times 5 would be 40x. And 125 times 5 is 25. And again, I'm in that situation of the last problem where actually that's not a perfect square. And again, if it had been 20, if this is a 20x, then we could just factor it normally. Let's look at one more example. I'm just going to create this one. So hold on real quick. Let me look at one more quick example. Let's see. I want to change the layout here to blank. Okay. So here we go. Let's say that I have x squared plus 6x plus 9. Okay, so let's look. Is this a perfect square? The answer is yes. Is this a perfect square? The answer is yes. Okay, so the square root of x is x. The square root of 3 is 3. So let's see. 3 times x times 2. Does that equal 6x? Well, 3 times x is 3x times 2 would be 6x. So yes. So this can be factorized into x plus 3, x plus 3. All right, thank you for watching.